So my question here is, in a sale, all prices are reduced by 20%. The sale price of a shirt is £14.40. What was the original price? Okay, so there's two ways that I'd like you to know for this, and I will show you both ways. The first way, I'm going to make an equation. So I can represent original price using a box like this. If you want, you can say original price is P and use P here, but I'm going to use a box. So original price times a multiplier. So if I reduce something by 20%, that leaves 80%. So to find 80%, my multiplier is 0.8, and this is the multiplier to reduce anything by 20% as well. And this equation is going to be equal to £14.40, okay, on this side. Now, if I want to solve my equation, what I do is I divide by 0.8 on this side. So divide by 0.8, and I'm going to divide by 0.8 on that side as well. And that will give me my solution. So this is going to be equal to £14.40 divided by 0.8. And if I do that on my calculator, I find that it is £18. Okay, here I have the question again. I did say there's two ways I want you to know how to do this, and I'm going to show you the second way now. So in a sale, all prices are reduced by 20%. That means 80% of the price is left. So the sale price of a shirt is £14.40. So what I can say is I can say 80% of the original price is equal to £14.40 for me. Okay, now this is not, perfect maths the way I'm writing it, but I know what I mean. I'm assigning 80% to £14.40. Now, my question is, what was the original price? The original price would be 100%. So I need to find a way to get from 80% to 100%. Now, one way that always will work is if I first go to 1%. So 1%, I would have to divide by 80 to get to 1%. I do the same on this side, divide by 80. So 1% of the original price would be 0.18, okay? Now, if I know 1%, it's very easy to get to 100%. So times it by 100 and times this side by 100. And I will get 100%, or the original price is equal to £18. Now, you might think of other ways of doing it as well. You might have said, okay, 80%, let's make that into 10%. So if you wanted to make that into 10%, this would be 10%, but this would be divided by 8. This would also be divided by 8. Remember, you have to do the same thing on both sides. Now, here's another example I'm going to do in the two ways. So this time I have Adam's new hourly salary after a 15% pay rise is £13.80. What was his hourly salary before the pay rise? So let's do the equation first. So let's say my original pay times, okay, so it changed, it went up by 15%. So an increase of 15% has the multiplier 1.15. Now, when I multiply by that multiplier, the answer that I would have got is £13.80. So to solve this equation, divide both sides by 1.15. And then the original salary is equal to £13.80 divided by 1.15, and that is £12. And if I did it the other way, I would have said 15% increase. So 15% increase from 100% would mean 115%. So 115%, I could have said 115% is equal to £13.80. So I make this equation. I set 115% to be £13.80. Let's go to 1% because that's always easy. 1%, so divide by 115. Divide this side by 115. So 1% would be 0.12. And now to get to 100%, which will mean his original salary, times 100, and then times 100 on this side as well, I will get £12. Okay, so either way, I get £12, and we need to be comfortable doing it both ways. Here are your questions. Now, I'd like you to answer both of these questions using the two methods. So do this one twice using the two methods. Do this one twice using the two methods. Now here, this is saying someone has improved their personal best for 400 meters to 56.4 seconds. So their old personal best has been reduced by 6% to give you 56.4, okay, because that's better, a shorter time is better. And in this one, we've got someone that's improved their long jump best by 6%. So the new best is 4.77, and that's been increased from an old best, okay, so there was an old best, and that's been improved by 6%. That means it's got further by 6%, and that's 4.77 now.